Hello, Randy.
Hello.
This is Jeff.
Hey, Jeff.
We were emailing a couple of weeks ago.
Oh, okay.
You were kind enough to accept my invitation to participate next month.
Well, and I am glad to do that. I'm struggling with my background right now. It's not.
Yeah, you look kind of like you're living in the Matrix or something.
Yeah, I think I better get rid of that. Let's see here.
Oh, you're trying to show an Astro photo?
Yeah, I've done it before, but it's been a while and it is not working. So I need to.
You know, in part it depends on the light on you because there you go. Now you got it.
What did I do there? That does look better.
I don't know, but you're there, and
Oh, all
what's
right.
that, the veil behind you?
I took that last night. I was out. I was having imaging withdrawal, and finally I could see a little bit of stuff last night, and I had a new Red Cat 51 I wanted to try. And so this is my first image with that, but it's wide field, so you can get the whole veil in there.
And this was last night.
Yeah. I got an hour on it, half of which there was a strong moon glow, plus I was shooting through a high overcast. So
wow, that's pretty impressive.
Surprised I got anything at all.
What kind of mount do you use?
It's an EQ6. I have it piggybacked on, I have a new C11 that I really haven't used yet. I got it all set up, and then we went on vacation for about a month, and then I got back July 4th, and of course we hadn't seen the sky for a long time.
The rain started, yeah.
Yeah, and I got this Red Cat, and I just have it piggybacked on the top rail, and I'm using the C11 with a Hyperstar as a guider. So it's
one might say that's overkill.
I'm imaging at 250 millimeters and I'm guiding at 540. but I'll have to say it's pretty accurate.
I'll bet.
So
I'll bet. Well, that's great.
So anyway, I finally got out and at least showed me that it can work. But yeah, it's an oddball arrangement. I want to pick up a lightweight mount at some point, but I don't have any.
So do you need, I hadn't really thought this piece of it through living in Tucson, but this time of year, do you need a dew heater?
No, I've never had a dew heater.
Really?
No,
okay.
I don't think you do. I guess maybe in monsoon, I've got a dew shield on there.
Right.
But nothing, do not have a dew heater, never had one for the 3 years I've been doing this, never needed it.
Good to know. Hi, Chris.
Hello.
Jim, Doug.
Oh,
Hello.
Folks.
Randy was sharing details of his background photo that he took last night. And for those of you who didn't hear, it was through the thunderstorm. He's got this new technology that can see right through the clouds.
That's okay. I like that, but it was a high overcast, and half of it, the moon glow was strong. So anyway, I was saying I got a Red Cat 51, and this is the first time I've been able to shoot anything with it. I just wanted to give it a try and see what I could get.
And what's the camera that you're using?
It's a ZWO 2600, so it's
the 2600.
Yeah, it's a pretty big chip in there. So if you look closely, the stars are pretty blocky. So you're going to undersample pretty severely at 250, particularly with that camera. So,
Chris, you were asking about a dew shield and dew heater. The only time I've ever had my scope fog up on me was during the monsoon season, when the humidity creeps up, and I was doing a public start party on grass, and the humidity from the grass below was kind of catching up.
Okay.
Generally on pavement or a good carpet or something, you're probably fine.
Okay, good to know. Thank you.
So where are you from, Jeff?
Originally Chicago, which dew is quite a problem. Been here about 3.5 years.
Well, so am I.
Oh yeah? What part?
Southwest side, the side facing Tucson.
There you go. So you had half a step ahead of me here. I lived in Deerfield up north.
Oh, okay.
Worked in the Loop.
Oh, well. No, I actually lived in the city. I was on the southwest side of the actual city. So,
Okay. Okay. Cool. Now both my kids live in the city now.
but yeah, I've been in this area since 1980.
It's a couple of years.
Yeah.
So you were only like 20 when you moved here.
28. Not quite.
Very good.
Now you know how old I am.
I can do that math. So for those of you who've been here a lot longer than I have, 4 solid days of rain, 4 solid days of cloud cover, that was pretty unusual, wasn't it?
Back in the old days, during monsoon, we'd get a pretty consistent shower most afternoons. So it'd generally be clear in the day, in the morning, and then the heat would cause it to flare up in the afternoon. We'd get some good afternoon and evening thunderstorms, but this was the low kind of helped force a lot of rain down pretty quick. I mean, we had almost 0.8 of an inch of rain and probably an hour and a half during part of that storm. So it was coming down pretty hard.
Right. Now, the first year I was here, we had exactly the pattern you described, that the clouds would build in the afternoon, we get thunder coming over the mountains, get some rain. But this is the first time I've seen what felt like a Chicago front.
Right. Yeah, this was mostly more like our winter rains, because except for the one storm that blew through here, most of it was nice and gentle rains, which is more like what we get in the wintertime.
Right. Just realized I did not have my video on.
Now you're there.
I spend the whole day doing this, so getting on a Zoom call in the evening is a little bit of a busman's holiday for me. So, hey, while we wait for Greg, I'm going to do a little commercial for next month's meeting. I've agreed to host about a 20-minute panel discussion aimed at lessons learned by more experienced imagers in this group that would be beneficial for newbies. I wish, if only I had known blank. It's not intended to be a rabbit hole discussion of this mount versus that mount or the like. It's really more general lessons learned, and both Randy and Alex have kindly agreed to be part of the panel. I was looking for one more person to join. It could be somebody pretty new to the game or somebody who's been doing it for a long time. So if you're interested,
Oh, I can, well, if you want me to participate, I'd be glad to.
well, it's a deal.
Give my 2 cents here. All right.
Thank you. I will, give me your email, Paul.
All lowercase characters. Paul, Paul, dot Lorenz, Lorenz, 45 at gmail.com.
Okay. So I'll put together a little framework and outline of topics and share it with the three of you for comments and advanced thinking so that we don't have too many surprises. But thank you.
Usually Greg is the first one on or close to it.
Well, we played this game before where we gave him a certain amount of time and then we just went ahead. So we'll give him the old college treatment, and if he's not here within 5 minutes or so, we'll start.
He's the presenter, isn't he?
I'm the first presenter, and
Oh,
then
okay.
I think I guess I have to look back at the agenda.
I think artists is going
Image
second.
processing challenge with the Rubin Observatory images as artists, and then the guest presenters are for imaging terminology, and that's what's on the agenda tonight.
Well,
Hey, Jim, this is Kevin. Did you get any takers on that Celestron?
I have not. You know, somebody that would benefit from it?
No, I was out golfing and I saw your email and yeah, not that I need another scope, but it's a good little scope for its intended purpose.
Yeah, I think it'd be a great one if somebody's got any kids or grandkids or family members that it's a good starter scope. I'll post something out on our Facebook page tomorrow if I don't get any takers from the forum. And then I told her she's actually from South Dakota, and I told her when she goes back there to maybe check with some of the parks or a local astronomy club up there to see. It'd be a great little scope for any of the parks that are wanting to get into astronomy at night.
Yeah, good point.
Okay, I can't stop my curiosity. I see on my screen there is an owner. Who's the owner? Who is that? Do you guys see the same thing?
Yeah.
yeah, it's popped up.
Oh, who owns this call?
There he is. Yeah.
It's a secret.
I know.
He's muted, whoever he is. Now he's unmuted.
It's unmuted, so.
Yeah, this is Chris Sherman.
Oh,
You guys hearing me?
yeah, I hear you.
Yep.
Yeah, that's my nickname owner. Clubs, checking things out.
All right, well, one more minute and then we'll get going. Is that acceptable to everybody?
Mhm.
Yep, sounds good.
Okay, well, I think I'll go ahead. Sorry.
I was just gonna say, I'll probably send something out to the club middle of next month, but for those of you that get the Astronomy magazine, we'll have an article in there on CAC in the October edition.
Nice. All right, so I think we'll get going here. I'm the first one on the agenda, so I'm going to share my screen. And I think if I share it this way, I can then start my slide presentation, and I think it should start up. Do you guys see this CAC Astro imaging display slide?
Yes.
Okay, so I had this idea a few months back that I brainstormed with a few of the folks out at CAC while we were astro imaging out there. And I talked to John and Jim and Conrad and several of the astro imagers. And so I want to kind of report my brain fart idea for a CAC astro imaging display. The idea that I came up with was mainly to try and make good use of that large format display in the RMO. But now that we have a new learning center coming along, I suspect that there'll wind up being a large format display in there as well. And it might be nice to showcase CAC astro imaging to club members and to the public. And so another incentive is that we wanted to encourage members to visit and take advantage of CAC's dark sky, and of course, because it's cool. Yeah. So trying to wrap my head around this of what the issues would be and how I would try and solve them, I said I would take a stab at this and then we would get feedback and go from there. The first and most important issue that I kind of bumped into was about rights. And it was important, at least to me, that imagers retain all the rights to their images. That people should know that the only granted use for submitted images is for this CAC slideshow. Any other use of those pictures that's on that slideshow needs to be by request. And so that will, I think, will establish that as one of the criteria for having it in the first place. I suggested an honor system where images must be of a personally captured astronomical object and some quote unquote significant fraction of integration time, which is undefined, but you know, to be determined by people under the honor system, should be captured while at CAC. So that doesn't exclude you from taking, you know, from capturing more information at home, but some portion of the image should be captured while at CAC. A naming convention helps to remember authors. So in this example, summers_m1.jpg, okay, makes it easy so that on the disk that we're keeping, if somebody finds the picture and they can go identify it, you know, they can easily identify who owns what on the disk. And then we talked about this a little bit and we decided that all submitted images will be used initially. at some later time, depending upon how dense the stack gets, and or if there's too much redundancy, that can be open for review. Okay, so some guidance. I thought that maybe it made sense to have object name labels on the images themselves, and I suggested a font and a watermark, an author watermark, if it's desired, should be opposite the name, and I'll show an example of that, and de-emphasize as compared to the object name itself. We're trying to keep the file formats small, so JPEG or TIFF. Ideally, we'd like to see these, less than 10 meg. That lets us keep a stick in the back of the TV, if you will, and that'll hold a whole lot of images. And then I recommended the 1080p format be used so that the screen would go edge to edge. And it looks much better. I did a test of this early and saw that my images were not 1080p, and it's okay, but it's not quite as nice as that big format can allow for. And so getting it to 1080p is pretty nice. All right, so I suggested that I could help people get through submission, and so they can contact me at kexguy@yahoo.com, and I will help. Really, it's not too hard to get through that simple process. The goal originally, I think, this could be put up on the RMO board for us in September, October. But I think, hearing Jim, I think the goal is to be operational by March of 2022, when there's some public function out there. Okay, so this slide here is intended to be in the stack. I briefed you guys that what the kind of the paradigm is, but I wanted to have one of the slides in the stack be sort of a repetition of what we already know, and that way, if Jim or some of the rotation of the CAC leadership changes, it's always known what the agreement was going into this thing. And so that is that folks can submit their images for inclusion, that the rights remain with the respective imagers, and who to contact if they want to get through the submission. And then, of course, a thanks to everyone who participated. So I thought, in addition, depending upon how many people we wind up having, I'm floating this idea that maybe we'll stick a picture of of a person and their gear, and have a montage, if you will, of of the Astro imagers and the gear as one of the slide set stack that just rotates randomly. At the moment, I only have myself in there, but of course, there will be others. Okay, so now to get an idea of what you can see kind of the label on the bottom right-hand corner. This is one of Paul's. Paul's name is on the left-hand side, slightly lower font. Here's another image of Paul's. Again, name on the right, and his identifier on the left. For mine, I personally don't choose to put my name on the images, but that's a personal choice. And so there's no name there, but there is a label. And this is another example where I didn't want to cover up the little galaxy on the bottom, and I thought the name kind of looked funky on the right with the title tail there, and so I stuck it on the left. So there's some, and again, these are just guidelines for how we would approach the labeling of the items. Okay, so that was my great idea, and then we had a lot of good discussion, and this item tripped me up. And so I leave it as a TBD and something that I'd like some feedback on. But the question is, what should TAA and CAC's position be regarding this public display? And I make note of that this is a public display in regards to image manipulation. And so I think there's maybe three, there could be 6 options, I don't know, but I can think of 3 right off the top of my head. And one is that we don't allow photos that could deceive the public. The second is that we allow those kinds of images, but we have a disclosure via label, let's say maybe under the name that says image enhanced by AI or some other kind of, label that lets them know that there's some enhancement that's gone on here, or we just ignore the whole issue and let it go as it is. And I include these two timely images. The one on the left is an image out of the paper that Matt Penn sent on SR3 this last week or so, was talked about in the forum. And the one on the right comes from Astro just a day or two ago that, clearly, if it's not obvious to you, that's Jupiter with Saturn's rings around it. And so the question about how much manipulation is too much manipulation needs to be thought about. I have a personal preference. My personal preference would be that, for item number 1, but I think fair negotiating is item number 2. I would prefer maybe we didn't deal with item number 3, but now's maybe the moment to get some feedback from the group about what, especially those who might be including their images from CAC on this display board. What do other people think about this public display?
I generally think of the Astro images I take as really an artistic statement. I try to, in my processing, get to appear as what I would describe as natural appearance as possible. But I know other Astro imagers deliberately use different processing techniques to emphasize certain other details. So it's a very artistic decision rather than some sort of attempt to mislead people.
Well, I've got an answer to that. When we process images, we're trying to bring out all the original detail that's there that might have originally been hidden. But what we're not trying to do is alter it in any way. We're just...
I would kind of respectfully disagree, because all it takes is a camera that's sensitive to hydrogen alpha more than the human eye. And so it's a natural part of the signal. We're capturing it because it's interesting, in terms of the detail it shows in some objects. But I'm kind of with the first comment. I mean, people who produce stuff with the Hubble palette, that's an artistic decision. And it's not meant to be deceitful. It's because it's either scientifically interesting or aesthetically interesting.
Yeah.
I don't find rings around Jupiter particularly interesting. I mean, maybe we have to rely on the audience recognizing stuff that's useful and within the bounds of being reasonable, and stuff that's kind of silly and past that boundary line, wherever it is.
Doug, in your mind, how do you distinguish between AI or other augmentation and the ordinary PixInsight Photoshop processing?
I think for me, the issue is that it's the intent of the processing. I've heard a lot of people talk about, well, any manipulation you do is, on the raw data takes you across that threshold. And in my mind, the purpose for why you're doing it is important. So I don't see calibration as a manipulation that could cause confusion or potential deceit in the public. That actually produces both clarity and accuracy. And I think that there's a wide variety of steps all the way through, nonlinear processing that keep you in that trying to get the most of your data, as Paul was suggesting. It gets a little slipperier if you take nonlinear processing too far, right? If you oversaturate, if you draw your curves too hard, if you do too much sharpening, then, you begin to cross a boundary. And this particular thing that we've been discussing in the forum for a little while now, or AI, this is a very interesting example to me. This is almost a sprite. If you remember the old Commodore 64 days, this 16 pixel by 16 pixel image was taken and it was generated into the image on the right of the little kid. This is using external data and adding details in, which there's a lot of, if you go read ethics, photography ethics, that's kind of a no-no. And this issue here, maybe I'll disagree with Kevin just a little bit, that I don't know that we as experts can rely on the uneducated or the ignorant, and I say that in the nicest way, public, to be able to recognize that the picture on the right is not Saturn. Yeah. So, and if we wanted to start playing games, we could really do a disservice to both the hobby and to the public by allowing too much manipulation. So I don't know if I answered your question, but that's my perspective. Some processing is fine. And I actually think this is a topic, by the way, I wanted to mention this. I really think that the Astro Imaging SIG could use a whole meeting probably to discuss the ethics and the issues surrounding what constitutes acceptable manipulation and what constitutes crossing a line. That maybe we'll throw that out for some future meeting where Greg, if he doesn't have a topic, might be interesting. I'd be interested in that discussion. So Jeff, did I answer your question, or did I distract?
No. That's good. It's a nuanced, vague line. At one level, there's the old Justice Potter Stewart's definition of pornography. I know it when I see it, and to some extent, you could use that to like the photo of Jupiter and Saturn mashed together. How big a problem do you think this likely is? Because the CAC photos are mostly going to come from our membership, right?
Yeah. And so I don't know. This is kind of my question. Right now, I've talked to as many people as I could, tug their legs, and I think there's only about 5 or 6 people who have expressed interest so far. I suspect that when we have this up and running, there'll be more interest. And my take on this is that, unfortunately, because I agreed to seed the presentation, I have a lot of images in there. And if this were to go too far in the direction where I felt it was inconsistent with what the philosophy of my original idea was, I would probably want to withdraw and let the rest of the group go on their merry way with no hard feelings. But for me, yeah, this is kind of a big deal because I've been in outreach for most of my career in astronomy, and I do see a little bit of a danger here that too much excessive use of either AI, even at the Topaz level, things could get tricky. And when the public is being, I feel like we have a responsibility to help the public understand the beauty of the universe. And when we start playing around too much with, then there's some danger here, and people can be confused. And I don't think we can just assume that they'll figure it out. I actually was reading a study, by the way. I've been looking at this pretty closely because it crosses over into some work I'm doing for Astrobin as well. And the cognitive scientists have some research papers out that show that people are terrible at this. They're really horrible at picking out fake detail in images, and that's why we're so easily gullible. This is another thing that kind of doesn't sit well. So I'd like to stay on the truer side and less on the fake side. All right. Well, I don't know if we're going to be able to answer this. This is something that I think people need to think about. We have time to come to some conclusions about this. If people feel strongly, send a note to somebody. Send a note to the CAC director. Send a note to me. Send your feelings, how you feel about this, to somebody who will be involved and can help us make a decision. We have a little time before we absolutely have to have this up and running. Is that reasonable?
Hey, Doug, one thought before we leave it is option 1, which I think you might be sort of leaning toward, is we do draw a line. And it's not only a matter of where we as a group think the line should be, but then somebody has to make that judgment as to where a particular photo falls relative to that line. And I don't know if that's the CAC director, but I feel a little bit uncomfortable with someone having to make that judgment. Maybe.
Yeah, well, this is, so you're great segue, because my next slide is going to speak to the next topic of TBD, which is what role can the ASIG play in the CAC Astro image display? So I suggested earlier that potentially, there could be multiple things that, that could happen. Maybe the ASIG takes some, some help here, provide some help in deciding that. But I suggested earlier that maybe we need a meeting to talk about this, because I think the CAC image display is not the only place that's public facing, right? There could be other places. I mean, think about it. The calendar, for instance, is kind of public facing. I'm not sure where where the other places are, but we have a wide variety of teachers who face the public, and who go out and and tell people about the beauty of the universe. And I think for astro imaging, it might be nice to see the ASIG give some guidance, right? Maybe there's a little bit of guidance that they could provide to say, all right, if we're going to deal with a public facing board, these are the kinds of things that we'd like to see on that as a matter of guidance. Maybe not so much. There's still an honor system. People who want to break the rules or do whatever they want to do are going to do it anyways. But I think in terms of providing guidance, this is something that could happen with the ASIG. So whether or not they help with the submission support, whether they, if we ever get to a place where we have too many images or too much redundancy, maybe they, make decisions about who stays and who goes. They could actually provide some help with the maintenance of the stick that's sitting in the back of the TV. Maybe there could be some help there, or there could be other ideas. And I may not have thought of what all could happen there. But the question really coming from the CAC director or what have you is, what role does the ASIG want to play in astro image board? And I don't know. We don't have Greg here, and Tom's not here either, so that's a little difficult. I don't know that we're going to be able to answer this, but it's going to be in the slide stack, and we can try and get some feedback from him at another time. Does anybody have any thoughts about what how they feel about the ASIG being involved in the process?
From
Well, I
the
have an
CAC
opinion.
director
Can I-
perspective, go ahead.
It's okay. I was just going to say, I think we have to decide first, are we putting on an art show, or are we trying to show, the images that were actually captured? Because to me, it's almost like the difference between science and science fiction. My goal with astrophotography is to try to faithfully reproduce what the object looks like. Okay. Otherwise, it needs some commentary. Like if I take an H alpha image of something with my mono camera, it's going to be a mono image. Everybody, I think, knows that's not what it looks like, but you might put a little explanation. This was a mono image captured through an H alpha filter. I think once you get into creating art, that's different. If I'm looking for posters, if I'm looking at posters of astronomical objects, it's easy for me to tell, the difference between art and what an image might look like. By the same token, if you see something created with the Hubble palette, you might also say, this was created with the Hubble palette, and that's why you're seeing green and yellow and blue, funky colors, and the object's not really that color. But, that's still not art. That's just, a scientific, somebody said, that's a scientific interpretation of that image, to bring out details that might not otherwise be visible, I think. So I think maybe we have to decide, are we trying to do art, or are we trying to show the images that we captured?
Well, I think I agree with you. That's where I started. I have the same exact impression as you do. The idea was about trying to represent what I actually captured faithfully. And I'm much less interested in representing, adding detail or taking away detail that might either be confusing, misleading, or otherwise draw away from the hard work we do when we sit in front of the telescope and actually take those images and then grind through that processing to do the best we can to represent what's actually there. Going beyond that is not that interesting to me.
Even so, like for instance, one obvious thing to me is you can have two guys you can throw the exact same set of data at, and they'll faithfully work at it to get what they think represents the best of what something should look like. And you look at the two, and they will not be the same when you get done with them.
almost guaranteed they're not going to be the same. But I think, there's a difference between taking a curve stretch and accentuating some slice of the data, which I would call, data science, and accentuating that differently from one person to the other. Maybe one of the people, it's all in the data set. It's all in that nonlinear data, but maybe one user takes the arms of M81 and attempts to accentuate them in a way that shows off the H2 regions, and another wants to show off the core a little bit more. And so they're stretching the data slightly differently and accentuating it, but that doesn't mean that, that they've created a dramatic art piece. It just means that they're accentuating something different that's really in the data.
Yeah, I mean,
that's my rationale.
Yeah, I mean, if I was to take a picture of a flower and a professional photographer was to take a picture of a flower, theirs might look a little nicer than mine, even if they didn't do anything tricky. But, that's just the data they captured. I have some pretty crappy pictures.
I think we all have those same crappy pictures.
So, that's the way it goes.
All right. Well, I think what I'd like to do here, if I can, I don't want to commandeer the whole meeting. I'd like to maybe leave it here, let you guys think about this. The slide stack will go, in the minutes and what have you. And if you feel, compelled either to share what you want privately, reach out to somebody and share those feelings so that we can make some decisions. And my take right now, we have about 75 images, and we can put up on a display in September as a starting point. And then the question becomes, what do we want to do with that set, and what could potentially alter our scheme there for who will participate and who won't, and we'll go forward from there. So with that,
you've got 75.
Yeah, I've got 70 of my own pictures that I told Jim that I would seed the display with, and those are all CAC images that I've taken out there over the last year and a half. And you've sent me 5. I'm waiting for Alan and Kevin to send me some of their good work, and I've talked to a few others, Connor and Tyler, who said that they would send me some. And so I think as we pull this together, we're going to have quite a nice randomized slide stack that'll run on that display. It's going to be a nice display. So
yeah.
All right, with that, I'll let it go. I'll unshare my screen and let the next person take over.
Before we leave this, Doug, just from a CAC perspective, my thought process, what we're really trying to do with these images is primarily to promote astronomy and the club, to promote CAC and what we can do at CAC, and then also promote astro imaging. And primarily these images would be shown when we're doing outreach events. So if we have a public event there, we just have it kind of streaming in the background, and maybe somebody designated to be there to kind of talk about some of the images as they come up and things like that, just to kind of help things along. I would prefer the SIG to be the primary focus on putting it together and everything, rather than the CAC director. That way you can come up with a better system for making sure we got good images, even if you have to do like a juried system or something like that you would for other images, or if you just have one person be kind of responsible. But anyway, that's kind of my parting shot from the CAC perspective.
All right. So I think next up is artists, and I forget the actual topic. Hang on 1 second. It's image processing challenge with the Rubin Observatory images. Artists, are you ready?
Yep, I am. Okay. Let's see here. You all see my screen okay?
Yeah.
Mm-hmm.
Okay,
Yep.
great. Well, to give you a little history, I talked to Greg about this several months ago. I work for Rubin. I'm a former teacher, and I now develop education activities that will make use of the observatory's data once we have real data that will go into classrooms. Most of our investigations are aimed at the high school and intro college level students. One of the investigations that we developed is called Coloring the Universe. And I'm going to talk to you a little bit about some of the interesting things we've learned in user testing that investigation. And then my idea was, I've been lurking in this group for several years now, and I don't contribute very much to the forum discussion because my level of expertise is well below most of yours. So I enjoy listening. I enjoy reading all of the comments back and forth, but I don't have a lot to contribute on the level that many of you are at. However, I thought you would be a great group to pose this challenge to. And so that's why I'm here talking to you tonight. So just a little background. Some of you might not be familiar with Rubin Observatory. It was formerly called LSST, the Large Synoptic Survey Telescope. And for a variety of different reasons, we changed our names. We are now the first observatory ever named after a female astronomer. The observatory is being constructed in Chile right now. It's at about the same latitude south of the equator as we are in Tucson, north of the equator. And because of COVID, just like most other things, we are delayed now in our schedule, and we're hoping to begin operations in late 2023 or early 2024. It really kind of depends on how everything plays out in terms of the pandemic, our ability to have workers from other countries come into Chile and do their work, equipment, supplies, et cetera, et cetera. I wanted to tell you a couple things that is different about Rubin Observatory compared to many of the other observatories on Earth. And that is that we're a survey instrument. So instead of the traditional model where astronomers apply for time and get maybe a couple nights or a week, this telescope will take a picture of the entire visible sky from its location every 3 to 4 nights. And it will do that continuously for 10 years. And in doing so, it will build up the largest database of astronomical objects that have ever been accumulated. So we have a new kind of mirror system too. It's a tertiary mirror system that enables us to have a very wide field of view, very sensitive, large light gathering power, very fast optics. So to give you an idea kind of the sensitivity of our mirror plus our camera system, if you think about the sky, and you can see a picture of the moon there, one picture from our telescope will take up almost 10 square degrees. So you can compare that either to the field of view of the moon, or another thing you can think about in terms of this picture that you may see here on the left. You might recognize Orion down here. And you can see part of that winter hexagon thing. That's about this. This is similar to the same field of view. So you think about that much area of the sky we're going to snap every 30 seconds. And what it's really going to enable us to do is not only be able to co-add hundreds of exposures over 10 years of time, but it's also going to enable us to find a lot of things that go blink in the night that most telescopes would miss because they're looking at such a small area of the sky for so little amount of time. We are going to have the world's biggest camera on this telescope. It's going to image the sky in 6 different bands, from ultraviolet to near infrared. And I'll talk a little bit more about that in a few minutes. But to give you an idea, a little bit about the specs of this camera, since we're asking you to think about images that will come from it. We have, this is our filter set that we're going to be using. And you can see the U filter is in the ultraviolet primarily. The last 2 filters, Z and Y, are all in the infrared. And the I filter is a combination, which I'll show you in a minute, of red through infrared. The camera resolution is really kind of stunning. So this picture you see here on the right are HD TVs, okay? So imagine that the resolution of this camera at 3.2 gigapixels will be 266 times better than an iPhone 12, if any of you own one of those, or the equivalent of 378 4K HD TVs for each image. And if you think about putting that many HD TVs together to create a display, that would be a little bit more than half of a basketball court. So this is quite an amazing system coming. And I think the people who are most excited about this is the astronomers, because I think they are more aware than any of us about what this flood of data is going to do to revolutionize science and the new discoveries we'll make and the research abilities that people will have. So all of this data is proprietary for 2 years, and then it goes public to the world. But proprietary means that it's immediately available to any country that's part of this system and has an affiliation with the telescope. So in the United States, what that means is if you belong to any observatory or university with an EDU affiliation, you have immediate access to this data. And if not, you wait 2 years. There are quite a few other countries that are doing work for the construction of the camera or telescope system, or they're working on software, or they're working on image processing or machine learning algorithms or data storage, any part of our system. All those people have also immediate access to our data. But our data is going to be a little different than a lot of the traditional, image processing programs that are out there for students to use, and many of you have used the same kind of things. So I wanted to show you this kind of how our band passes of our filters compare to visible light. So a lot of times, for instance, we think of an R filter as passing red, but in our case, the R filter is passing everything from green through red. Likewise, our G filter is passing everything from violet through green. And so when you start mixing light from these filters together, it produces results that maybe you weren't thinking about because it's not exactly intuitive. So it just, kind of as a setting the stage, which I think all of you know, there's what some people will call true color, or, if you had like a color one-shot camera and you get that image and try to, as some of you were saying earlier, faithfully reproduce the image, what should it look like? And then there's narrow bands where you're taking very, very narrow bands, like some of the Hubble palette things, or this image that I just pulled off Astro I think a week ago or so, where, primarily a lot of people use that combo of H alpha and oxygen 3 and sulfur 2 to create these really spectacular images that show structure and detail of certain elements. And then there's in broadband imaging, what most astronomers will follow is what's called chromatic broadband, where the colors assigned to the filters have to follow in chromatic order, meaning that the shortest wavelength of light that's passed by a filter has to have the shortest wavelength of color, let's say violet. And the longest wavelength of light passed by the filter has to have the longest wavelength of light that we can see red. And so we've developed a 6-color imaging tool that we are using in part of our classroom investigation. We also would like to just put this on our website so that people could play with it and create pretty pictures. And some of the things that I have learned being in charge of testing this tool is that it's not as easy as you might think it would be. Because first of all, like one of the things I mentioned before is that when you mix these broadband filters that have multiple colors in them, it's not the same as saying, well, I want to add a little bit more blue to my image, or I want to add a little bit more yellow to my image, because whatever color you assign that filter is bringing in the light from all the different wavelengths that filter transmits. And so that's kind of an interesting thing. And, what it really boils down to is what some of the things we would anticipate seeing, like, an H2 region being red, or a bright hot star being blue, it doesn't show up quite in the same kind of colors that you would see. And so, I mean, you can see like what I did here is I just, put in a couple lines to show the difference between these narrow band filters and what we would get just in one band with these broadband filters. And so creating a color image that you would like to see is maybe not as intuitive as it seems. And in addition to that, scientists are not at all interested in making pretty pictures except when they need to for the public. Because, someone mentioned this earlier at the beginning of the meeting, when you're doing a scientific color scheme, you're trying to faithfully reproduce certain structures or features or energies in the image. And so a good example of this is the Sloan Digital Sky Survey. And I wanted to show you their filter set, which is very, very similar to ours, but also different. And I'm going to be using some of the Sloan images tonight to show you what a typical science image would look like versus a typical general public image. Now, since I'm in the Education and Public Outreach Department, what we want to do is create pretty pictures for the public. There's something very compelling when you look at Hubble images, for whatever reason you want to put your finger on, they're appealing to people. People like them, they think they're pretty or beautiful, but not so compelling when you look at science images. And I wanted to show you that the way that the SDSS color scheme works is they take only 3 of their 5 filters. So they ignore the ultraviolet, they ignore the infrared, that's light that human eyes wouldn't see anyway. And they assign the blue, green, and red to these other 3 filters, which are actually passing, certain large bands of light, similar to how our telescope will pass large bands of light. And so here's a side-by-side comparison. And the big differences you'll see is that our telescope has 6 bands instead of 5. So we go much, much more into the infrared, to the point where at 1 micron here, we're seeing a lot of dust extinction. So a lot of the nebula disappears, where you don't see that quite as dramatically in, the SDSS images, but you can see some. We are a little bit more sensitive to the wavelengths of light on either end of the band passes here. And we, right now, since we don't have our own data, we are trying to experiment with developing a color scheme that would be appealing to the public and yet not totally whacked out, not totally fake, but using the data we have coming off of the telescope and dressing it up a little bit so it looks pretty. And our images are engaging and compelling when the public looks at them. So our color scheme here is remarkably similar to the Sloan Digital Sky Survey scheme. And when I say our color scheme, I'm talking about the color scheme that's right now in development by scientists. So again, they are planning on using just the 3 bands that would overlap somewhat with visible light. They are planning on discarding the other 3 bands from doing any kind of color imaging. And when you assign in chromatic order, blue, green, red to those bands, some interesting things happen. So we are going to talk mostly about galaxies tonight because of the pretty pictures we can make. We're going to start with galaxies because we can pull pictures from current data in Sloan to be able to show examples of what I'd like to talk to you about tonight. So a typical spectrum of a galaxy, a spiral galaxy, these 2 blue lines identify kind of like the part of the light from a galaxy that we would get, including this part here, which is the infrared light, and this little part down here, which is the ultraviolet light. So that darker part of the spectrum is the visible light part of the galaxy. So galaxies typically get much brighter when you go into the infrared. And they typically also get much weaker in terms of color or light output when you go into the ultraviolet. And so thinking about that, if you added an infrared band in, it becomes overwhelming to the other data that's there visibly. And if you add ultraviolet in as a band of color, you don't really get a huge contribution from it, with the exception of some special galaxies. Another problem is that we're used to thinking about blending only 3 colors to produce an image. But here we're trying to give people the ability to use 6 colors and blend them together to produce an image. And so it's as if your eye, instead of having 3 kinds of cone cells to detect light, would have 6 different kinds of cone cells to detect light. And so it's a little bit different than a lot of the color tools that are out there already on the internet. And so, as I mentioned, one of the problems is that mixing these broad bands of light don't produce the same kind of color mixing as you might anticipate. But another issue is, what if you want to show the infrared bands? They don't fall, and again, this is something someone mentioned earlier, that they don't fall within the realm of human vision, but they certainly are there. And the data that they're transmitting is faithful and true to the actual representation of that object in space. However, if we could see that object, it wouldn't look at all like that because we can't see those infrared bands. And so that's kind of an interesting thing to think about too. So I wanted to show you some examples of what we've looked at in the scientific color schemes that are out there and what is different about the scientific scheme versus the optical schemes that a lot of people use. And so here's an example of, the Cocoon Nebula. And if you look at it, we would tend to think of that as a red object because of all of that ionized light. But since the red portion, H alpha, falls into our G band, if we associate the traditional scientific color scheme, reds become greens. And likewise, greens become blues. So there's something interesting to think about right off. Another thing we've noticed is that the scientific color schemes tend to produce a couple different kinds of galaxy colors. One is that spiral galaxies, which we typically think of as primarily bluish, with yellow centers, a lot of them turn out orange. And other spiral galaxies have this kind of muted orange nucleus, blue arms, but they look just a little bit different than we tend to think of when we look at images of galaxies we see in astrophoto galleries. Another thing that's kind of curious about spiral galaxies with this muted blue-orange scheme is that because of the blending of colors, the star-forming regions we would typically see in galaxies turn out kind of an aqua or a turquoise color. And so actually, to those of us who know a little bit too much about what colors represent, these just look wrong in some ways to us. Of course, most people don't know that, there are red areas in a galaxy and blue areas and spiral arms and what that means. So it doesn't matter that much. I don't know about you, but I prefer to look at the image on the right and like that better than the image on the left. Now, some people like more of that diffuse glow kind of deal. But this is kind of hard for us to dissect. Like, what is it that really makes an image appealing to people? And there's no one right answer, right? But there's kind of a commonality set, I guess I would say. And then some of it has nothing at all to do with the color mixing, but it's just the processing routines. So the things that come off of SDSS in the pipeline get processed with an arcsine stretch, and they get, there's a certain sequence of things that are applied as an algorithm to every single image that comes off. So it's kind of a bulk processing scheme, and not a lot of time is spent adjusting any one image. That's great for scientists because scientists don't need pretty pictures. They need to look at colors that represent certain structure or wavelength regimes. And for them, that works. But what we'd like to do is develop some kind of process that develops better looking pictures, if you will. And so that's kind of what I'm tossing out to you tonight. So summary of some of the things we found, the differences between the scientific schemes and the general public appealing type schemes, is that you have this color shift because of these broadband filters. You also have galaxies in kind of weird looking blue-orange colors, or turquoise in some cases. And you get overall just a very fuzzy, blurry, lack of crispness in the images. And some stars, because of the high amounts of infrared they're kicking out, or ultraviolet, have really high color saturations and look very, very strange. However, some people really like that. They like that kind of neon pop of things, which leads us to kind of thinking about this, and that is, what is it that makes images visually appealing to people? And is it more interesting to see what you'd expect to see, or to see in the other wavelengths that only telescopes can see in, only detectors in the infrared and ultraviolet can see? And so you look at a picture like this from SDSS, and now this is adding in the ultraviolet band, but none of the infrared. And of course, that doesn't look at all like what we would expect to see. But at the same time, it is revealing information that we are unable to see. And then we could get into that whole what would you expect to see anyway discussion, because our eyes are really lousy at detecting colors. And so there's that whole issue too. I want to come back to this, but I'm not sure how much time I have, because we ran over a little bit on our first discussion. So let me just finish up with a few things. I had originally approached Greg and said, Greg, do you know anyone who might be interested in helping us out a little bit? Because what we're looking for is somebody who can develop a scheme, if you will. I know a lot of you are really into PixInsight, but it wouldn't have to be using that. But some kind of scheme that in the future we could say, all right, we're getting all these scientific images in 6 bands off of our data. We would like to create some images for the public that look visually compelling. How do we do that? Now, the standard scheme that a lot of the big observatories are using now is eliminate the infrared, eliminate the ultraviolet, and go with the 3 overlapping visible light wavelengths. Maybe that's not really what we should be doing. Maybe there's a way that we could be taking in some of that infrared information, or even ultraviolet, and enhancing it somehow, and creating images that really pop and tell a different story. It's just kind of an interesting thing to think about, like what bands should we use and what's the rationale for that? I'm giving you some information here on this screen about the SDSS images, because what we're going to do is we're going to give you some files, if you're interested in playing around with them, of what a typical scientific data would look like. I'll warn you that many of you take much better pictures just in the raw images than what you'll see from SDSS. But there are whole stacks of these files. And if you want to go back and dig into the technical details, you can go back and get the individual images instead of the stacked corrected image. And then we'd like to see if you have ideas for us. There's no prize, there's no money in this. We're not going to use anything you give us and claim that it's ours. But if you can come up with a scheme that might work for us, then we may want to contract you to do some work for us in the future. So we'd just like to see what you do. You're such a brilliant, creative group of people. And I like the fact that you all don't think the same about things. I think it's good to have diverse opinions and perspectives. And so if you're interested in playing with this, I've created a folder where you can download the images and also a background document of tech details. We can send this out via the forum message too, so you don't have to grab it right now off your screen. And if you're interested in making an image and telling us what you did, then do it. And if not, that's fine too. But I thought some of you with time on your hands and the creativity you have might be interested in doing this. So like I said, we could send this out as a follow-up message as well, but I wanted to stop here because I know we're at the top of the hour now, and I'd like to invite your discussion.
So I have just a quick, a quick comment, and that is, when I see a picture of star field, okay, the first thing I'm thinking of is HR diagram and color, yeah, color and temperature. And so when you shift the colors dramatically, I lose track of the HR diagram and the temperatures of those stars. And I think in some sense, there, it would be nice to find some way to achieve what you desire in terms of, working with the filter sets you've got, but finding a way to keep the intrinsic information that people have come to know and love about color and temperature, those relationships together. So I don't know, I don't have an answer there. I was thinking about it. I wonder if some kind of proportional stretch could occur on your filters so that the colors are shifted. You've got an I band that's green, and maybe you still want those to be red, but that would require you to have to shift do a hue shift or something so that you have a proportional amount of color that's still similar to what you had before. You can still keep some of your infrared, deep infrared, and and the blue side data, but blend it in some kind of proportional way that remaps your filter set and still attempts to keep something similar to SDSS. I don't know how you think about that, but anyways, just some random thoughts. Maybe my last comment is about when you mentioned all this data, I'm thinking to download that data is going to be a tremendous problem for people outside the place where the data is stored. And I'm wondering if you guys are thinking about either having a local machine with GPUs on it that people can log into to do some of this processing, because if we have to bring gigabytes worth of data down, that's going to dramatically reduce the, the ideas that are flowing to you.
Yeah, I'll speak to that, Doug, just for a minute. There is going to be so much data coming off the telescope. I always forget the number, but it's huge. The astronomers make an analogy like drinking from a fire hose. So there's going to be so much data coming off every night, and it's transmitted within seconds of detection. I think in less than a half a minute, it's transmitted all over the world. So we have a series of what are called brokers, and brokers are not people, but they're software filters, if you will, that will only pick out the kind of information that that particular broker is looking for. So for instance, we have a broker for supernovae. We have a broker for, asteroid detections. We have a broker for certain kinds of high energy optical things that happen. And so there are really a lot of different science pillars that this telescope is going to help with. And so the science community has organized itself into 8 different brokers right now, including one broker for things that we don't know what they are, that are going to come up every night. And so if you, for instance, really loved asteroids, you would feed off of that asteroid broker that's coming in every night. It's not going to give you great pictures. It's going to give you the snaps, the very short pictures, but it'll give you the data so you could do follow-up detections. Another really interesting thing about our telescope, I was super excited when I got this job because I've been an amateur for a long, long time. But one of the first things I learned is that anything I knew in the sky is not really going to be visible with this telescope because it saturates at magnitude 17. So everything that's coming off of this telescope is going to be between magnitude 17 and 27.5, and typical exposure about 24.5. So we're going to see a lot of dim things, but with incredible resolution. And that's kind of exciting. And so LSST is the name of the survey. The telescope, the observatory is called Rubin, but what this survey is going to do is it's going to fill in a lot of pieces of the puzzle that astronomers don't know, whether that's in solar system science or high energy physics or, you know, dark energy, dark matter. It's going to bring a lot more objects to us, and we're going to get a lot of new things. But even that, with 10,000 supernova detection a night, how are you going to decide which one you want to see?
Well, I think, number one, thank you for the presentation. It's amazing and exciting, and I wish it was 3 hours longer. But I think it boils down, it dovetails really nicely into our other discussion, because it boils down to, what do you want to show? Do you want to show what it really looks like, or do you want to make pretty pictures? Right? Because if you're getting into pretty pictures, you know, that's an artistic interpretation, and my pretty picture is your hideous picture, you know? So if you're trying to just show what an object actually looks like to human beings, that's interesting. But also, you know, if I'm looking at, you know, Cygnus X1, which is a great X-ray source, right? So if it's to me, it's also interesting to see a picture. If you could see X-rays, here's what it would look like. That's cool too, right? But I can't see X-rays. So, you know, if you're wanting to, if it's an outreach and you're wanting to show people what things really look like, then, I mean, you should show what they really look like. Not, if you had, you know, eyes that could see into the infrared and the ultraviolet, here's what it would look like. Well, that's great, but that's not what I would see. So, you know, the answer might be both, right? So, because it might be, well, here's what it looks like to you, and if you could see this way, here's what it would look like. You know, that's cool too. So that's my feedback. I want to see the other 3 hours of your presentation.
Well, I'd be happy to come back or talk to any of you individually too. It's been fascinating. It's been a really cool ride the last couple of years. And you know, one of the things I struggle with a lot in evaluating these programs is that I'm seeing everything through that lens of, I know a lot about astronomy. I know a lot about what I've seen already on the internet about how images should look. But I wish I didn't know anything about astronomy and I could approach it from that person who just sees a picture on the internet and goes, wow. You know, like, what makes them go, wow? Is it the superhuman vision of the telescope with all these different, should we be creating infrared palette pictures and just show the 3 infrared bands? Here's if you had infrared eyes. I mean, that's another way to approach this, you know. There isn't a right answer. You know, and I know a lot of you have been involved in outreach for a long time. And that's part of the wisdom of this group too, is the experience you've accumulated in interacting with people who are excited about astronomy, but maybe don't know a lot. And what is it that they would point to and go, that's a really awesome picture. And it's hard to put my finger on what that is. That's why I'd like this discussion to continue even beyond tonight. You know, I welcome your thoughts. Would anyone else like to share something they're thinking?
This is just what occurs to me, but both listening to Doug's presentation for the first half and then yours. And I see two kind of possible solutions. One is when you show an image, you have a tab that shows sort of the visible light analog image. As Doug said, it's not going to be simple to generate that with your filter set, but as close as we could sort of come up with what that would look like to the human eye. And then you could have other tabs that say, okay, this next one emphasizes UV bands, or this next one emphasizes IR, because that shows astronomers detail in a star forming region or some other aspect that's interesting to us. And then circling back to Doug's challenge, maybe the answer is kind of like the technical card on Astrobin. You say it was captured with this hardware, it was processed with this software to emphasize X, to show structural detail in the spiral arms, to show star forming regions, to show something. And that sort of flags that it's no longer in the realm of a realistic image to a human eye, but it's scientifically useful because of that emphasis, if that makes sense. You know, between the captioning and the tabs where you could sort of flip back and forth between a visible light image and, you know, just your IR filter image, people would understand why we're looking at the IR filter image, because it shows us something we didn't know about otherwise.
Yeah.
Well, I got something to add also. You know, any detector is biased to some extent, whether it's the human eye or it's some kind of a man-made detector, like you know, an electronic detector or film. Everything is biased, and there's no one thing that detects everything evenly in the entire electromagnetic spectrum. Everything is a part of the spectrum, and usually a small part. So we've invented detectors to replicate approximately what our eye does. Like we've invented, like for cameras, we try to replicate what we see with our eyes. So therefore, nearly every detector that's used is approximately within the range of what the eye, except unless there's something that's designed for a special purpose to show something that, like, for example, there's the space telescopes that are like the Webb is going to be more in infrared. There's the Chandra that detects in short wavelengths, and they're all meant for certain purposes. But in that same respect, it is still objective for that range of the spectrum. Nothing can detect the entire electromagnetic spectrum. So we have to kind of work from that standpoint all along. And our eyes detect only a small part, only approximately 4,000 to about 6,500 angstroms. That's it. And then, you know, there's enormous amount on either side that the human eye can't see. So whatever we're working with, it's a subjective detector, just like now even some animals, you know, the way an image would look to them would probably be entirely different from the way we see a landscape. Even some of our close relatives, other fellow mammals, even like a dog or a cat, probably each would see the world around us very differently. So,
and even within the realm of astronomical objects, you know, some objects are bright at the infrared end, some objects are bright at the ultraviolet end, some objects are more kind of flat spectrum. And so even take the detector out of it, if you could create an even detector, not all objects emit evenly, right? And so that's one of the problems we've been running into with these galaxies and using infrared filters. If you add a little bit of the infrared in, it just overwhelms all the other colors of the galaxy, because galaxies are so high at the infrared end in terms of their energy output. And so that's something also that's not intuitive to people. You wouldn't know necessarily what the spectrum of an object looks like. And a really nasty one is reflection nebula, because depending on what wavelengths of light they're scattering, can be bright in places you might not think about other than blue, let's say. And that's a mess to sort out too. So there's a lot of interesting challenges in this. But if we could come up with at least some broad stroke ways of dealing with this color palette or filter selection, Even if we get like, 85% of the work done and then somebody has to touch up or finish off all the images, if we could somehow put a script into a pipeline that says, all right, this is going to the public, so we're going to process it in a different way than we process for the scientists, because we know certain things that the public would like to see or would expect to see. So yeah, I cut off somebody else. I'm sorry.
Actually, if you don't mind, Greg is not here, and so I feel a little responsibility and a little badly for the people who were supposed to go next in the agenda. And
Yeah.
I don't know how much longer we want to continue the discussion. I'm with Alan. I think it's fabulous, and I would love to talk about this all night long. But for those who actually volunteered to do, the technology terms discussions, do you feel like you can go ahead and make quick presentations, or do you feel comfortable in delaying your conversations, your presentations for another meeting? This is something, I don't know who was supposed to go.
Well, this is Randy. I'm totally comfortable with deferring till,
Okay.
till whenever it's needed.
all right.
That's work.
Thank you.
That works for me.
We'll blame a part of it on our fearless leader for not being here and getting a little bit of a late start. What
No.
about other people who were on the agenda for terms? Anybody still left that was supposed to go?
Mine won't be that long.
Okay, would you like to go tonight? Instead, and do people want to hang around long enough to hear that presentation? Can people hang out?
Mhm.
Okay, well, if we can, then, if you don't mind, artists, thank you so much for presenting. I suspect that I know I've got some ideas for you, so I'll probably send you email separately. Maybe if we can, unless there are other questions and comments for artists, we'll move to Chris.
I also have I'll send out my email. So any of you feel free to contact me. All right. Thank you so
Great.
much for giving me the
Thank you.
chance.
Oh, thank you. All right, Chris, you're up. What were you going to tell us about?
Okay, can I go ahead and share my screen here? All right. Wonderful. Doesn't seem to be working that well. All right. So I'm talking a short topic tonight about bias frames and dark current. And so I'll get into the quick and dirty definitions here. A bias frame is a calibration image, and it's taken with no light allowed to enter the camera at the shortest possible exposure time. The bias frame shows the fixed pattern noise in the image, and it can be used to subtract fixed pattern noise from regular images. Now, your dark current is electron noise in an imaging device that's caused by thermal effects. And the amount of dark current in an imaging device is determined by its semiconductor design, and it increases linearly with increasing temperature. The way we calibrate out dark current noise out of an image is by use of a dark frame. And a dark frame is an exposure that's taken with no light allowed in the camera that is the same operating temperature and of the same exposure length or longer than the regular images being taken. Let me see if I can get this PowerPoint to work right here. Evidently not. Well, that doesn't help. Kind of lost control over it. Let's try this again here. Okay, so there's some implications of these definitions here. It's reasonable to ask, does a dark frame also include the fixed pattern noise as well? And the answer is yes, it does. If you're using a dark frame that is of the same exposure length and temperature as your regular image, there is no need to use a bias frame in your calibration. Now, if your dark frame is of the same temperature and a longer exposure length than your regular image, you can create a scaled dark frame if you have a bias frame available. In a scaled dark frame, the bias frame is first subtracted from the dark frame, and the remaining signal in the dark frame is scaled proportionally to the shorter time of your regular image. An important note here is, if you're using a CMOS type camera, your bias and dark frames must be taken with the same offset and gain settings as your regular images. Okay, so I'll look at some demonstrations here. I took these the other day. This is a bias frame taken with a QHY183C CMOS at 12C temperature. This image is stretched 0 to 300 ADU.
Sorry, we're not seeing your image, by the way. I don't think you're sharing your screen anymore.
Hang on a second. Hold on. Let's get back to that. Got it now?
Yep.
Okay.
Mhm.
So this is a bias frame that was taken at 12C, and you're seeing this stretched 0 to 300 ADU, and the peak ADU of any pixel is 242. Pretty low bias noise. All right, and these are dark frames, and you can see here that these 3 dark frames were taken, same exposure length, but at different temperatures. So your dark current, your dark noise is higher at a higher temperature and is lower at a lower temperature. Here you have 2 dark frames that were taken at the same temperature, but one has twice the exposure time of the other. So you can see that this frame is lighter. There's much more of this dark noise present in this dark frame than there is in that frame. So this shows that your dark current, your dark noise increases with exposure time. And finally here, I don't know how well you can see this here over a connection here, but I have 3 regular light frames that were calibrated. This one has no calibration at all, and I don't know if you can see it, but this does have various hot pixels in it. This is a one-shot color camera.
Mm-hmm.
This is one that just has a regular, same exposure length, same temperature dark frame subtracted from it. And you can see this is a pretty clean image. And this one here used a scaled dark, where our dark frame was twice the exposure length of the light frame. And then we used a bias frame on that to create a scaled dark frame. And on this one, it's pretty good, but not quite as good as the one using the same exposure length dark frame. And that's it. Questions?
Okay, thank you, Chris. Another thanks to Randy, who is willing to push his off. I know what that feels like. I got pushed off last time, so I apologize, Randy, to you. Thanks so much for being flexible and letting us reschedule that. Is there anything else that we want to chat about before we break off?
Oh, I got a question. Can somebody tell me something about quote unquote layering as used in Photoshop? And I don't understand understand what that means. I've heard the term layering.
Let's reserve that for a technology term, yeah, because I suspect somebody can, and I'll write it down and send it to Greg, that he can deal with that.
Yeah.
Okay, well, if there's nothing else, I think we'll break off here. And, thanks to everyone for coming. I don't know, artists, if you have just a moment, we have an open forum here, and so we can hang on. I would like to ask you another question afterwards, but we shouldn't hang on to everybody, especially if they're not completely interested in hearing that conversation. So if you're available, I'd love to chat with you for just a second longer.
Sure.
And for everyone else, thanks so much. We'll see you guys next month, yeah? All right.
Thanks for
Thank
a
you.
really interesting presentation, both
Yeah.
of you.
Yeah.
Great
thanks.
evening.
Mhm.
Okay, so artists, I was thinking about this, and something that struck my thoughts when I was listening to the whole dialogue here is, when I do a photometric color calibration, I think the problem that you've got here is that when you've got overlapping bands visible with something else, right? This is where all the trouble comes into play. And if I'm going to do a photometric calibration, where the white point is adjusted, and then I've got true visual color, right, to represent, like we talked about before, the HR diagrams, color, temperature relations, and what have you. It seems like you want to hold on to that. When you get out of the realm of the visible and you're completely over on the right and you want to go crazy and make some bizarre Hubble palette or whatever you want, then that's easier for people to deal with. But when you're overlapping the visual spectrum, people expect to see the visual there. So this is where I was thinking about that proportional stretch. The one thing I think you might have going for you is that if you think about deep blue and violet, those colors don't really show up hardly at all in the visual spectrum, right? I mean, if you go out on Astrobin and you start looking for deep blues and violets, other than the occasional person who crazily colors their galaxies, intensely blue, you don't really see that. And so you could take advantage on the blue end with that deep blue and violet kind of coloring. And then if you think about on the infrared side, there is what I would call a completely saturated red. I mean, these deep, deep reds that they look fake, right? People don't expect their HA to be so densely, darkly red. And maybe if you had some kind of a proportional stretch where you tried and mapped the visual as close to a color calibration extent as you could to keep the center wavelengths normal, if there is such a thing, and then attempt to leverage out into the deep blue and violet on the blue sides and deep red on the infrared side, would you have enough to, maybe you short circuit a little bit on your red and you stretch your reds down slightly into the orange, if you will, and that way it gives you a little more headroom on the top for those deep, deep reds to show those longest wavelengths. I don't know. I'm wondering if folks have talked to you about, those kinds of schemes, but it seems to me that anchoring that visible in the visible, even if you have to stretch it a little bit, would be something to do when you overlap the spectrum.
Yeah, and I think that's what a lot of different scientific color schemes have done to recreate images for the public. But we're starting brand new, so we can do anything we want. And maybe that's not the way to think about it. I'm trying to throw away a lot of what other people have done and say, let's think out of the box. Is there some better way to do this?
Yeah. No, it's true, and I just think it's gonna definitely be interesting to show the Cocoon Nebula in green. Right? People are not prepared for that, and it's going to take a little while. And of course, in the beginning, right, it took a long time for people to get used to the Hubble palette as well. But I don't know. I think it's interesting, and this whole issue of how to deal with that. I think you've got quite a challenge on your hands. I wanted to ask you real quick about coming back to my other question, which I wasn't quite sure you understood, and that was about the access. So, you know, if you're capturing terabytes, many terabytes worth of data, for any individual observer to bring down a terabyte worth of data and try and process it, even for an experiment on color schemes, let's say, is pretty overwhelming. And just to, you know, just thinking in terms of the processing of that, we all have our laptops, right? You know, to process in PixInsight a terabyte image, okay, is a daunting task. I can't even imagine what that would be like. You know, I have enough trouble with my 60 megabyte images, right? And you know, at some point, if you really want the public to be engaged, those brokers that you were talking about, they probably should include some kind of guest resource, computing resources that people can log on to so that they can do local processing as opposed to attempting to download the images and then do remote processing, because we're just going to be completely overwhelmed in, you know, remotely even attempting to do anything with that data, right?
Oh, absolutely. We've thought about this just for our public facing website, and you know, the solution we can see is to come up with a curated set of images that people can play with, instead of just having them randomly go try to sort through everything. We know that there are some users that are very technical, and they could access the API the same way a scientist could and get data exactly like a scientist. But for most people, especially if you're not really good with Jupyter notebooks and Python, it's just not a reasonable ask. What we've done for the education side is nothing has to be downloaded. We've provided all the embedded tools and access to the images simply by going to a website, and everything's in an online browser.
Okay, so it is local. You're saying that the data is kept local and the API allows local access. Oh, that's good. And that in turn also must imply that the browser or the tools that are running locally have access to sufficient computing resources so that it doesn't take a year to process this, you know, this image local on your server. Yeah.
Yeah, it's
because you can imagine a situation where if you had open access to a browser, though, that computing resource is going to need to be pretty robust, because if it's open to 100 people, you know, and they're all accessing, you know, half a terabyte image or something, then that's your server is going to get hammered pretty quickly.
We haven't developed all of our infrastructure yet for the back end support on this, but we are using Google Cloud, where we can, let's say if you had an account, we could just spin up a new container for you. And cloud compute is great because it's on demand. Need more, you get more. If you don't need it, you don't pay for it. And
so are you pushing these terabytes into the cloud? Is that what's happening? Is that the scheme?
No, well, we have our own data center, and it's also backed up in France, and it's backed up somewhere else. There's like a couple backups besides the main data center. And I am not sure exactly how the scientific data is accessed, but the EPO, our own department, will have its own data center, if you will. And we're using cloud compute to be able to spin up. If you imagine, let's say 100 schools hit this at the same time, and each school has 150 students using it. That's all of a sudden a huge demand, right?
Right.
So we have to be able to quickly be agile and be able to support that without anything crashing.
But that implies that some portion of your data, the portion you're going to expose to outreach, will have to be uploaded into the cloud, so that when they access it with these server farms, you have the compute resources to get the job done.
Yeah, and one of the things that we are excited about is, you know, traditionally in an education program, everybody's working on the same set of data, but we're going to have so much data, we'll be able to provide everyone with a unique set, and that's going to be cool. It's going to be a ways down the road yet before we can do something fancy like that, but it's pretty sweet the way this is going to work. And in the same way that we're thinking about students and teachers, we'd like to think about, well, what happens if you know, people, just interested scientists, science interested individuals want to come in and play with data and just see what happens when you do this or that with our different tools we've developed. How do we provide access for them? And so this is a conversation I've had with a lot of amateur astronomers, and a good example is I've gone to AAVSO and said, what would you, in your heart's desire, what would you want? And a lot of them will say, well, I want to discover a new kind of variable star. Well, how do you go about doing that? Because, with millions of variable stars per night, how do you search through the data or what star you want to track, without having to develop your own processing routines? And even brokers are going to kick out so much data per night. For you to pick something would be daunting. So I think that's part of the education and public outreach, where we pick the most interesting objects, or maybe the most popular objects, as we can perceive what people want, and put them in a place where you can get to them and you can easily work on them.
So
Now,
it seems to me that, go ahead.
One of the interesting things about the images is, you and I both have our favorite images, right? Everyone on this call right now, you could think of, oh, I'd love to process this image or that image, but those aren't the images that are going to be available with Rubin, because these are all going to be really deep images of objects we've never seen before. Typically, as amateurs, we have not seen them. Let's put it that way.
No, it makes sense. I'm wondering to what extent, I'm sure you must be using AI classification to sort of do a first pass on the, on those buckets, if you will, on those broker classes.
Yeah, there's actually a lot of machine learning algorithms that are going on right now. And that's how the brokers are going to get their stuff. What a subset of amateurs are really excited about is there's always going to be a limit of sensitivity for AI, right? So there's going to be some things that fall below detection because they're too noisy or whatever. And then being able to go through the fields and find the things that the machines missed is very exciting for some amateurs, especially for people looking for like asteroids, things like that.
Right. Well, you can imagine blink sequences, you don't have to go all the way to AI necessarily, but if you've got blink sequenced movies or something, then those could quickly get classified into the transient categories, right? So
yep.
That'll be interesting for folks. I'm sure that the amount of time it's going to take to mine that data is going to be forever. So,
yeah,
quite the chore.
I think from a processing standpoint, you get a little bit intimidated by the 3.2 gigabyte size of an individual frame image, but it really depends on how that image has been chopped up and stored, so to speak, because a camera on the LSST is not a monolithic single chip. It's an array of chips, just like we have up at ODI here. And even though we have a 1 degree field, there's 30 separate chips taking the image on that, and you don't have to take that data off of all 30 chips. You can just get 1 or 2.
Yeah, the question is, do you have a low res sort of preview that you can extract your region of interest from, right, and then get the higher resolution in a region of interest that you want, right? It's again, it's a searching game.
I know all the alerts come with a thumbnail image, so very low res, very small section. But the broader question is, I don't know if there's any plan to do what Chris is talking about, where you could just extract the image in one detector, one chip, if you will. I know what we've done already is we've taken big images and we've cut them into pieces so that the data is more manageable for students to work on. So like we've taken one image and chopped it into 16 pieces. So you get 1/16 of the image. And of course, it's not our image, but it's an image we're stealing from, I think, STI. So I think it's a Hubble image we've chopped up. I'm not positive.
So, well, just out of curiosity, will you have a a photometric redshift filter of some kind or another and then do follow-up at another telescope? Or is there going to be spectroscopy capabilities, right, with the telescope itself?
We have photometric redshift. So because you even know that term, you know how it works, right?
Yeah, right.
But what we're doing is just taking the photometry and we create a crude curve and compare it to models. And then from that, you get the redshift. And then,
but who does the follow-up for spectrum? Okay, so somebody though is going to wind up getting tagged to do the actual spectroscopy on those deepest of the red, for instance, right? To figure out how far out those items really are. And I'm just curious if who's tagged to do that.
We have amazing accuracy on these photometric models. I mean, I forget what it is, but it's less than 2% error, even on the really deep galaxies.
I didn't realize it was quite that good.
Yeah, I didn't either. And I actually was doing some research on this because we have an activity that uses that for our classroom sequences. And, the problem with having such wide field of view is there's no way you could do spectroscopy on all those objects. There's too many of them and they're too dim. And the amount of time
you need a hell of an IFU, yeah.
Yeah,
right.
but
I mean, there are IFUs out there, and so if you, for instance, had somebody like ESO or CAC or whoever, right? There are some big IFUs out there. You could look at the most interesting of the objects, over time. Yeah.
Yeah, and everybody is going to do their own follow with whatever they're interested in, because there's a lot of different areas of science we're going to touch in terms of the sky.
Okay, well, I think I've exhausted my questions. Thank you so much for hanging out for just a moment and chatting with me a little bit more. I don't know if anybody else has any questions.
I have a couple of improved versions of some of those images I sent you.
Okay, well, just send me them, Paul, and I will replace them in the stack that I've got.
Yeah, I got the M33 shot. I got that annoying kind of purplish cast in the background sky. I got it down to almost nothing. And I also have a fantastic shot of the Andromeda galaxy.
Okay, great. Well, just send those to me and I'll get them in the stack. I think for you, my recommendation would be to figure out how to get rid of your satellite trails.
Yeah, I don't know how to do that. I'm sorry.
I know how to do that. We should just spend a moment with you the next time I see you at CAC, and we'll.
Is there a way to do that?
Oh yeah, of course there's a way to do that. So,
well, if you
but
can
it
help
implies
me out with that. If somebody want to help me out with getting rid of those, I'll be.
This is September, buddy. I'll see you out at CAC in September, and if nobody helps you by then I will help you figure out how to get rid of your satellite trails by then.
Okay. All right.
Okay. Thanks so much, you guys. We'll see you on another call, I'm sure.
Okay.
Take care.
Okay.
All
Thank
right.
you guys. Bye.
Right.
Bye.